Alright, in this problem, I have 9 to the power of x is equal to 27. So I want to find the value of x here. So for my solution, first start with 9 to the power of x is equal to 27. And now what I'm going to do is I'm going to rewrite 9 here as 3 to the power of 2. So now I have 3 to the power of 2 to the power of x. And this is equal to 27. Now, 3 to the power of 1, that's equal to 3. 3 to the power of 2, that's equal to 9. 3 to the power of 3, this is going to equal 9 times 3, because as the exponent goes up, the result is multiplied by 3. That's how powers of 3 works. So 3 to the power of 3, that's going to equal 9 times 3, which is 27. So I can rewrite 27 here as 3 to the power of 3. So now I have 3 to the power of 2 to the power of x is equal to 3 to the power of 3. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x, which is simply just 3 to the power of 2x. And this is equal to 3 to the power of 3. So now, what I'm going to do, now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, these two exponents equal each other, so 2x is equal to 3. Now to solve this equation, all I have to do is divide both sides by 2, these two cancel out, and I'll have x is equal to 3 over 2. So this is my answer. Now to check, first start with 9 to the power of x is equal to 27. So x is equal to 3 over 2. So now I have 9 to the power of 3 over 2 is equal to 27. Now 9 to the power of 3 over 2, this is the same thing as 9 to the power of 3 squared. Or sorry, the square root of 9 to the power of 3. Now 9 to the power of 3, 9 times 9 is 81. 81 times 9, that's going to be 729. So I have the square root of 729. And square root of 729 is 27. So I have 27 is equal to 27. And because this is right, my solution is right. Alright, so for this problem, I have 6 to the power of x is equal to 12. So to solve this problem, I'm going to first start by taking the log on both sides. So now I have log 6 to the power of x is equal to log 12. Now if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this is going to equal b times log a. So in this case, log 6 to the power of x, I can move x to the front. So that's going to equal x times log 6, which is equal to log 12. Now, to solve this, I'm going to divide both sides by log 6. These two cancel out, and I have x is equal to log 12 over log 6. Now log 12, that's the same thing as log 6 times 2. Now I have this over log 6. And if I have something in the form log a times b, this is equal to log a plus log b. So log 6 times 2 I can write as log 6 plus log 2. Now I have this over log 6. Now log 6 plus log 2 over log 6, this is the same thing as log 6 over log 6 plus log 2 over log 6. Now, log 6 and log 6, these two cancel out. So now I have x is equal to 1 plus log 2 over log 6. And log 6 over here, I can write as log 2 times 3. And I'm going to do the same thing again. I'm going to read this as log 2 over log 2 plus log 3. And again, if I expand it, I get 1 plus log 2 over log 2 plus log 2 over log 3. Log 2 and log 2, those two cancel out, so I have x is equal to 2 plus log 2, that's equal to 0.301 over log 3, that's equal to 0.47. So if you simplify this, you get x is equal to 1.3868. So this is my answer. Alright, so in this problem, I have x squared minus 1 is equal to x minus 1 squared. So I want to find the value of x here. So to start, my solution, first start with x squared minus 1 is equal to x minus 1 squared. Now I'm going to go ahead and expand x minus 1 squared. So if I have something in the form a squared minus b squared, I'm actually going to expand x squared minus 1. So if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, x squared minus 1 is the same thing as 1 squared. So a is equal to x and b is equal to 1. So now I have x plus 1 times x minus 1, which is equal to x minus 1 squared. Now, if I subtract x minus 1, I get x plus 1 times x minus 1 minus, if I subtract x minus 1 squared minus x minus 1 squared is equal to 0. Now x minus 1 squared, that's the same thing as x minus 1 times x minus 1. Now if I factor out x minus 1 from this, I get x minus 1 times x plus 1 minus x minus 1. This is equal to 0. Now this is equal to x plus 1 minus x plus 1. And which is equal to, these two x's cancel out, so all I'm left with is 1 plus 1, which is 2. So I have x minus 1 times 2 is equal to 0. So now to solve this, I'm going to have to distribute the 2. So 2 times x is 2x, and 2 times negative 1 is negative 2. So I have 2x minus 2 is equal to 0. So now to solve this, I simply add 2 on both sides. These two cancel out, and I have 2x is equal to 2. Now from here, all I have to do is divide both sides by 2. These two cancel out, and I am left with x is equal to 2 divided by 2, which is 1. So this is my answer. Alright, so in this equation, I have 1 to the power of x is equal to 3. So this might seem like an impossible equation, right? Because how can 1 be to the power of any number and equal to 3 if 1 to the power of even a million is still equal to 1? Well, let's try to solve this equation the way we would solve any other exponential equation. The first thing I would do is take the natural log or ln on both sides. So I get ln 1 to the power of x is equal to ln 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this is going to equal b times ln a. In this case, I have ln 1 to the power of x, and I can move x to the front. So now I get x times ln 1 is equal to ln 3. And now if I divide both sides by ln 1, these two cancel out, and I get x is equal to ln 3 over ln 1. Now, if you guys already didn't know, ln 1 is equal to 0. So I get x is equal to ln 3 over 0, and you can't take any number and divide it by 0 because that's undefined, meaning this has no solution. So that method doesn't work. However, this just means that there are no real solutions. But there are different types of solutions. So what I'm going to do to solve this equation is, first, let's recall Euler's formula. And if you guys don't know what this is, it states that if I have something in the form e to the power of I times theta, this is equal to cos of theta plus I times sine of theta. And I know this may seem a little complicated right now, but just bear with me. So let's say that theta here is equal to 0. So if theta equals 0, then I get e to the power of I times 0 is equal to cos of 0 plus I times sine of 0. So then I get e to the power of 0 is equal to 1, cos of 0 is 1, plus sine of 0 is 0, and 0 times I is 0. So 1 plus 0. And e to the power of 0 is 1, so I get 1 is equal to 1 plus 0. Now, what if we say that theta is equal to 2k pi? K being a constant, so it could equal any number, 1, 2, or 3. So if I plug this in, I get e to the power of I times 2k pi is equal to cos of 2k pi plus I times sine of 2k pi. Now, what if k is equal to 1? What if our constant k is equal to 1? Then I get e to the power of I times 2 pi is equal to cosine of 2 pi plus I times sine of 2 pi. Now, cosine of 2 pi is 1, and sine of 2 pi is 0. So I get this is equal to 1. Now, if k is equal to 2, I would get cos of 4 pi plus I of sine 4 pi. Cos of 4 pi is 1, and I times sine of 4 pi is again 0. And if I do the same thing with 3, I would again get 1 plus 0. So this pattern continues, and it keeps on equaling 1 no matter what value of k we get. So we can say that e to the power of I times 2k pi, this is equal to 1 no matter what value of k we have. So now this means that we can substitute this in back to our original equation, which is 1 to the power of x is equal to 3. This is our original equation, and we can substitute in 1 for e to the power of I times 2k pi. So now I get e to the power of I times 2k pi to the power of x is equal to 3. And this is my new equation. So now, to solve this, I'm going to do what I did at the start. I'm going to take the natural log or ln on both sides. So I get ln e to the power of I times 2k pi to the power of x is equal to ln of 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so I get b times ln a. In this case, I can move x to the front, so I get x times ln e to the power of I times 2k pi is equal to ln 3. Now I'm going to use this property again and move this to the front as well. So I get I times 2k pi times ln e is equal to ln 3. And ln e, these two cancel out. So now I'm left with I times 2k pi is equal to ln 3. Sorry, and I also have x. Now I'm going to divide both sides by I times 2k pi. So when these cancel out, and I get x is equal to ln 3 over I times 2k pi. Now I'm going to multiply this by I over I, which is the same thing as 1. So I get x is equal to I times ln 3 over I times I squared. And if you guys already know, I squared is equal to negative 1. So over negative 2k pi. And k, in this case, can't equal 0, because if k were 0, this wouldn't work. So this is my solution to this equation.